Hello dear students, this is Dr. Saurabh Sir's classes. We are going to tell you that we are Dr. Saurabh Sir's classes team and we will help you throughout your all of your examinations preparations. It's like examinations like TIFR GS, NBHM, ISI, CMI, etc. So please feel free to contact via these contact details, and our contact number is you can see that, which is 98367930076. Again I am telling that 98367930076, and our email ID is sorrowclasses@gmail.com. Please feel free to contact via these contact details so we can help you and enjoy the services of Dr. Soros's classes. Okay, so now we are going to solve an problem which is from our TIFR GS 2025. So the given question in this screen, which is it is a true false question. So we have to find out the logic because for which the statement is true or false. So the statement is telling us that every subgroup of S1 equals to Z belongs to C and Z bar is equals to 1. Okay, so S1 is the circle. Okay, so viewed as a group under multiplication is finite. Okay, so every subgroup of S1 viewed as a group under multiplication is finite is the statement. So now we are going to understand the structure of S1. Okay, so let me, yeah. So our S1 is the unit circle in the complex plane consisting of all complex numbers of modulus 1. So we can write it in this form. Theta will belongs to our R. Okay. So under multiplication, S1 forms a group, specially an abelian group. We know that. So the product of two elements of S1 will also belongs to S1. And the inverse of any element Z belongs to S1 is Z bar belongs to S1, and the identity is my 1 belongs to S1. So 1, okay. So now we are going to find the subgroups of S1. So the subgroups of S1 can be classified into two types. The type 1 is finite subgroups. This consists of the roots of unity. For example, the nth roots of unity form a finite subgroup which can look like e to the power 2 pi I k by n, yeah, where our k is equals to 0, 1, dot 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 up to our n minus 1. Yeah. So now we are going to understand the infinite subgroups of our S1. This consists of elements of the form of this e to the power I theta. This is my e, sorry, e to the power I theta, and our theta will belong to d, and where our d is a subset of R is a dense additive subgroup of R. We know that our dense additive subgroup of R is, we know that will look like our Q. Okay, such subgroups are infinite and dense in S1. So now we are going to give the counter examples of it. So the subgroup this, that means which is looking like our e to the power 2 pi I q, where our q is a rational number. Yeah, this where our q belongs to q is infinite. So thus this subgroup is dense in S1 and consists of all complex numbers of the form of e to the power I theta, where theta is a rational and multiple of 2q. Thus, there exist infinite subgroups of S1 disproving this statement. So the conclusion is that statement is false, which is told us that every subgroup of S1 is viewed as a group under multiplication is finite. So this statement is a false statement. Hope you understood, guys. And again, I am telling that if you want any of this kind of this kind of logical explanations of any problem, so please feel free to call on this number and or drop a mail on this email ID. Hope you understood, guys. Thank you.